So the topic is about the first order kinetics. That is, the first order reaction is defined as a reaction in which the reactant depends upon the concentration, in which the rate of a reaction depends upon the concentration of a reactant. So here only one reactant, so we can write it as minus dC by dt is equals to K1 into C. So minus indicates that decrease in the concentration of in case of a reactant. Okay, so minus dC by dt is equals to K1 into C, multiplying on both sides with minus sign. So minus into minus plus we will get, so plus dC by dt is equals to, here plus into minus minus, minus K1 into C. So we are separating the variable, then we will get dC by C. See here, this C we are taking here. Okay, dC by C is equals to K1 minus K1 into, here dt will come here, so K1 into dt. Okay, now integrating on both the sides, we will get integration of dC by C. This will be the initial concentration and the final concentration taking as Ct, and minus K1 into integration of dt. This will be the T0 time, at time 0, final time T. Okay, so the formula is for integration of dC by C, it is in the form of dx by integration of dx by x. So for this we have to write ln of x. So it is in the form like dC by C. So dC by C, integration of dC by C can be written as ln of x, that is ln of C. Okay, ln of C, and initial and the final concentration is equals to minus K1 into T. This will be the time, initial and the final one. Okay, now this can be written as ln of Ct, here ln of Ct minus ln of C0. See here, minus we are doing from final to the initial concentration, from final concentration to initial concentration is equals to minus K1 into T. Same, from final to initial time we are taking, so T minus 0 will be T only, so K1 minus K1 into T. Now this is this shifted to here, so now we will get ln of Ct is equals to ln of C0 minus K1 into T. Okay, it's in the form, when we plot a graph, if you are taking time on x-axis, time on x-axis, and ln of Ct on y-axis, then the slope will be K1 minus K1. Okay, the slope will be minus K1. So the slope is equals to minus K1. So here ln of Ct is equals to ln of C0 minus K1 T. Okay, this is the from this we will get a first equation. So from this we have taken the graph, we plotted a graph, ln of Ct versus time. Okay, the slope we got is, slope is equals to minus K1, here minus K1. On x-axis we are taking T, and on the y-axis we have taken ln of Ct, and we got the slope K1. Next, we are converting this equation, this first equation, to the logarithm base 10. Okay, so when we convert ln natural logarithm to logarithm base 10, see here we need to multiply with 2.303. Okay, so log Ct is equals to log C0 minus K1 T by 2.303. See, when we are multiplying here, so we will be dividing with 2.303 also. So the both 2.303, this will be get cancelled, and here also this will be get cancelled, and we will get minus K1 by 2.303. So finally we will get log Ct is equals to log C0 minus K1 into T by 2.303. This is a second equation. From this also we can plot a graph. On x-axis we are taking the T, and on the y-axis we are taking log Ct. So the slope we will get is K1 by 2.303. The slope we will get is 2.303. Now from the equation log Ct is equals to log C0 minus K1 into T by 2.303. When we rearrange this equation, we will get K1 is equals to 2.303 by T into log C0 by Ct. So to estimate the concentration of the reactant which is remained, so that is K1 is equals to 2.303 by T into log A by A minus X. So here A will be the initial concentration and A minus X will be the final concentration. And now is half-life. So what is half-life? It is the time required to reduce the concentration of a reactant to half of its initial concentration. So initial of concentration we are estimating. Okay, so it is the time required to reduce the concentration of the reactant to half of its initial concentration. So here we are taking Ct, that is the final concentration, as it becomes off. So C0 by 2. Initial was C0. So C0 by 2 and T is T of. When we place those values in the form, in the equation, K1 is equals to 2.303 by T into log C0 by Ct. Here in this equation we have placed, so it forms the T of, and in the place of Ct it was C0 by 2. So in this equation now 2.303 by T of into log C0. Here C0 will be get cancelled and 2 will come up. So now it becomes, and we replace this one to here, then the T of will be 2.303 by K1 into, when it comes up it forms log 2. The value of log 2 is 0.3010. Now multiplying here with 2.303 into 0.3010 by K1, we get 0.693 K1. The T of is 0.693 by K1. Now the shelf life. So what is the shelf life? It is the time required to reduce the concentration of the reactant to 90% of its initial concentration. So that is the shelf life. So here the final concentration Ct we are taking it as 90, up to 90% it was reduced. So 90 by 100 C0, then T is T90. Okay, then we substituting these values in the formula, that is K1 is equals to 2.303 by T into log C0 by Ct. In this equation we are substituting. Now it forms the K1 is equals to 2.303 by T90. In the place of T we are writing T90 and log C0. Ct is 90 by 100 into C0. So 90 by 100 into C0. Here C0 will be get cancelled and 0 get cancelled. 9 by 10 becomes, when it goes up it becomes 10 by 9. So T90 we are shifting it to here, from here to here. Okay, so then now it will become T90 is equals to 2.303 by K1 into log, when it goes up it becomes 10 by 9. 2.303 by K1 into log 10 by 9. What is the value of 10 by 9 is 0.04575. Now we can write it as 2.303 by K1 into 0.04575 into we are doing. Now we will get 0.105 by K1, that is T90.